Good evening, my YouTube viewers. In this particular video, what we're talking about is maximum likelihood estimation, which is a method of estimation. So maximum likelihood estimation involves finding the parameter values that maximize the likelihood function, which measures the probability of the observed sample given the parameter values. So we're going to do this using Python. And we're going to import 3 libraries. So the first library that we're going to import is import NumPy as NP, which is the numeric library. And then we're going to import matplotlib.pyplot as PLT, which is the visualization library. And we're going to import SciPy. So from SciPy.optimize import minimize, and from SciPy.stats import norm. So SciPy is Python's scientific library. And then what we want to do is we want to generate synthetic data such as heights and centimeters. So the first thing that we want to do is we want to set our seed. And what you do when you set your seed is it initializes the values. So every time you run the program, it will set up the same initial values. So that's, you type in np.random.seed brackets 42. So you set up your true mean, which is 170, and you set up your true standard deviation, which is 10. And so data equals np.random.normal brackets log equals true mean, comma, scale equals true standard deviation, comma, size equals 100, and that's your that's your sample data. So, and then now we're going to define the log likelihood function for a normal distribution. So def log likelihood is going to accept params as its argument. Mean, standard deviation equals params 0, params 1. If STDEV is less than or equal to 0, this prevents invalid non-positive standard deviations. Return np.inf, and that's infinite. And then return negative np.sum, brackets norm.logpdf, brackets data, comma, log equals mean, comma, scale equals std underscore dev, brackets. So now we're going to take an initial guess for the mean and standard deviation. So initial guess equals, and it's a list of np.mean data, comma, np.std data. And then now we check out the maximize the log likelihood function, so we minimize the negative log likelihood. Result equals minimize, brackets, log likelihood, comma, initial guess, comma, method equals L, BFGSB, and then bounds equals none, comma, IE -5, none. And MLE mean, MLE standard deviation equals result dot X. So we print the mean and the standard deviation, and so MLE mean is 168.96, and MLE standard deviation is 9.04, but the regular mean is 170, and let's see what the regular. So the true mean is 170, and the true standard deviation is 10. So they estimated the guess mean and standard deviation are slightly different from the true mean and standard deviation. So now what we're going to do is we're going to plot the data and the fitted distribution. So x equals np dot linspace brackets min data, comma, max data, comma, 1000. And fitted PDF equals norm.pdf brackets x, comma, loc equals MLE mean, comma, scale equals MLE standard deviation, and PDF means probability distribution function, and it's a statistical function. So now we're going to plot a figure, and we're going to create a histogram of the sample data. So plt.hist brackets data, comma, bins equals 20, comma, density equals true, comma, color equals light blue, comma, edge color equals black, comma, alpha equals 0.7, comma, label equals sample data. So now we fit the normal distribution, plt.plot, brackets, x, comma, fitted PDF, comma, color equals red, comma, label equals fitted normal distribution, next line, the mean and the standard deviation. So now what we do is we add labels, title, and legend to the graph that we have just plotted. So the title is maximum likelihood estimation, normal distribution. The X label is value. The Y label is density. And then you get a legend and a grid, and then you're going to show it. So this is the blue are your bars of data, and the red is your fitted normal distribution with a mean of 168.96 and a standard deviation of 9.04, which differs from the true mean of 170 and the true standard deviation of 10. So that concludes this video. The next video, we're going to be talking about Bayesian estimation. So I hope you decide to watch it.